Hello guys, today we'll be solving this new past paper, October-November 2023, 33. So let's start. So the first question, they gave you a couple of compounds and they have questions about them. Gives a lilac color in a flame test. So on this type of question, like, you need to know the colors. You need to know the colors from your textbook or like get the help from YouTube or whatever. The lilac color always indicates that it is a potassium. Okay, so like one of these must have a potassium in it. When you try to find them, you will find potassium iodide, so this must be your answer. Okay, now B. The B says forms a cream precipitate when its aqueous solution reacts with acidified aqueous sulfur nitrate. There's nothing here to understand, but you need to learn this. When like this equations happen, it must be something with sodium, okay? Because sodium does give a cream precipitate. So it's sodium bromide. So for this stuff, this are like you need to learn them. There's like a whole graph you need to learn about them. So you need to study it. It's like so much, but at least like let's study the main ones. Okay? So until now it's only learning. Then C says is an acidic oxide. Acidic oxide, it's non-metal. Like if it was basic indicates that it is a metal. Okay, so let's search here which one of here are non-metals, which are sulfur. Sulfur is in the non-metal side of the periodic table, so this must be the answer. Sulfur dioxide. And also for your own knowledge, CO2 and whatever is on O2 is for your knowledge is acidic. Thus it's an acidic oxide, which is a non-metal. Now is an unsaturated hydrocarbon. You need to know this from the last chapter in chemistry, but I don't remember the chapter name, but it's about the carboxylic acid and the ethane whatsoever. Unsaturated means that it is indicated it is an alkene. You need to learn this. And if it was saturated, it means that it is an alkane. Okay, so let's see which here is an alkene. We have propene because it ends in E, so it must be propene. Now E is a product of an incomplete combustion. Whenever you see an incomplete combustion, you need to know that its product is a carbon monoxide, CO. And if it was a complete combustion, it is CO2. The product is CO2. We need to learn this. So incomplete combustion must be carbon monoxide. So you will put carbon monoxide. Now is used for a test of presence. That must be an easy one, Mark. Go up. Now you're gonna think if it's either this or this. But need to know it's always starting with an anhydrous copper sulfate. Hydrated copper chloride will not help you in like providing water because it's like already hydrated. Like it will make no sense. So make sure that's first thing anhydrous, and copper sulfate is like the perfect match. So put anhydrous copper sulfate. Anhydrous copper sulfate, okay? Now for question 2, give the letters of all particles which are okay. Atoms. So atoms means that there is no difference in protons or electrons. So protons equals electrons, because if there was different electrons means it is an ion. For example, Cl minus. There's a difference between electrons and protons because electrons are added in one than protons. Okay. So let's see which are the same. So we know that A is the same. Protons and electrons, they're the same. They are not the same because here there's 13 protons, here there's 10 electrons, mean there's a decrease in the electrons number. So it's an ion. So you don't want that. It's also wrong. That's wrong. This correct. So it's A, B, and F. A, B, F. Okay. And then ions with a charge of 2 minus. 2 minus means the added 2 electrons. So let's check. So 13 into 10 is not added 2 electrons. 16 into 18, 16 plus 2 equals 18. So this must be the answer. D is the answer, because it got added by 2 from protons into 18 electrons, so it must be D. Now cations means whatever you want to say it. Cation means that it like an ion with positive charge, and anion is like the opposite of this, an ion with negative charge. Okay, so let's see which one have a positive charge. It is C. Why? Because first thing it was 13, right? And we know, for like example, if it was like Na plus means that it lost 1 electron, right? That shows here that for C it lost 3 electrons, and that shows why it's a plus sign, so it must be C. And now state the atomic number of A. Atomic number is the proton number of A. Is an easy 1 mark question. It's 5. And now C, determine the number of nucleons in D. Nucleons is the mass number, which is the protons plus neutrons number. And now in D says it's a neutron and proton number of D. So it's 17 plus 16. And your answer is 33. And now D, state the electronic configuration. The configuration is the electrons, but we need to put them in shells, like for example 2, 8, 8, and so on. Of D once again. So in the electronic configuration, we need to look at the electrons, not the protons. Okay. So there's 18, right? So put the first thing to start with 2. Then put the electron in the first shell is always must be the maximum of 2. The second shell must be the maximum of 8. And the third is maximum of 8, and so on. Now it's 2, 8, so now it's 10 now. We have 18, right? So now it's 8. So it's like a full outer shell because it's an ion. Okay, so like here it gained 2 electrons to become a full outer shell, indicating that D is an ion. So let's pop it in. It's 2, 8, 8. Okay. State the group number of F. The group number is like the one that goes horizontally, like IV. This is the group number. Okay, group number of F. And how we'll know the group number? The group number always group numbers always need to look at the outer shell electrons. Okay, always actual electrons. For example, if there's like two atoms with like 2 in their end, means that they are in group 2. Okay, so what's the question again? So the group number of F. So it was number of electrons is 15, right? So it's 2, 8. So it's now 10, and then 5. So there is 5 in here, right? So it's a group 5. You care about the outer electrons, okay? So it's group 5 in here. So if there's 5 in the outer shell, mean it's group 5. So 2E is 5. Now state the periodic number of B. Periodic number is like the opposite of group, so it's this. It's the numbers in here that goes like this. It goes horizontally. Let's move this. Say the periodic number of B. So now when it goes with the periodic number, and now for the group number we care about the outer shell electron, right? But if for the period number we care about the amount of shells. For example, if it was 288, I mean, look at an atom, 288, 287, there is 1, 2, 3 shells. so it indicates that it is in the third period. And if it was like 2-8, like 2-7, so there's 1-2, so it's in the second period. Okay, so now going to the question, state the period number of B. So 10, it's 2, 8, 9, 10, so it's 2-8, so there is 2 shells, so it's in period 2. Okay, and now question 3 is about the Haber process. Now the question is, nitrogen is obtained from air. Okay, state the percentage of nitrogen in clean dry air. You need to learn it, that it is 78. Learn it. Okay, now state the source of hydrogen from Haber process. The mark scheme is written as natural gas. Okay, but I'm sure you can also write methane. Okay, because like methane, because the natural gas is like made up of methane, so it's also correct. And for your own fun fact, methane is like CH4. And for you like to not forget it, so the hydrogen comes from the CH4 from deer, so you will never forget the from where it's made from. Okay, now this one, wait a minute, let me check the periodic table first. So now the H is 1, right? And down for a nitrogen, let's go back to the question because you did not learn it. Okay, so the nitrogen is here, right? So nitrogen, we care about the proton number, okay, which is the electron. So now we have 7, right? So we could put it in electron shells, so it's gonna be 2, 5, right? 5, 6, 7, yeah, it's 2, 5. So now we know that 5 needs 3 electrons to get a full outer shell, right? 5, 6, 7, 8, so it needs plus 3 to get into 2, 8. So it must share 3 electrons to get a full outer shell from the 5. Okay, I know it's gonna be confusing, but I'm gonna show you how. So we know now that the outer shell electron of nitrogen is 5, right? So it needs still 3 to do. So first thing let's do is hydrogen because it's easy. Hydrogen, let's make it as like dots. Okay, so hydrogen shares 1. Hydrogen needs only 1 to get full 2 electrons, so it only shares 1, and that's it. Okay, you put it like anywhere you want, but like main thing, make it correct. I love to put it in like the same circle. Now the nitrogen, since it have 5 electrons in outer shell and it needs 3, so you do 5 minus 3, which is 2, right? So the nitrogen has still some 2 electrons out. There's 3 more from the 5 which need to react. It's gonna be like this. Now how will you check? So 1, 2 for hydrogen is correct. 1, 2 for hydrogen is correct. 1, 2 for hydrogen is correct. Now for nitrogen it's gonna be 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons, so correct. Now some 2 easy marks. And now IV is write the chemical equation for the reaction occurring in Haber process. Haber process about the production of ammonia, just for your own knowledge, and give the typical reaction conditions. Need to learn this, please. Learn all of this. Now the chemical equation, need to learn it with the balancing. The N2 plus 3H2 equals 2 NH3. If you don't know the balancing, you can like make the balancing by yourself later, but please, like, it's better to learn it as the exact equation so you won't waste time. Okay, so this is the equation, you need to learn it. Now the reaction condition, you need to know temperature is 450. Make sure to write the units. Okay, so I guess we did a mistake now. Okay, the Haber process reaction, which is this sign is so wrong. Why? Because the reaction is reversible. Okay, so like this, you did a whole mistake, and this whole thing in the mark scheme, it says it is 1 mark. So if you wrote like a normal arrow, you will get deducted a 1 mark. So please remember that the equation is reversible. okay? Now the temperature, coming back to temperature, is 450 centigrades. You need to learn this. The pressure is what was it, 20 atm? No, it was 200 atm. atm is atmospheric pressure, so 200 atm. And if we're gonna make it in pascals, kilopascals, the scheme says 20,000 kPa. That's for your own knowledge, but this one is easier. But also learn this. Now the catalyst, need to know that it's for iron, okay? Now there's also another process called the contact process. It's not in this question, but need to learn it because there's like two processes you need to learn: contact process and Haber process, okay? Okay, B. Now this question is about reversible question. I mean the equilibriums question. It's so easy. The chapter is the easiest for me anyways. I says, suggest why the following element is most likely to be used as a catalyst. Draw a circle around your answer. You would be confused by the first, but you need to know that catalyst is a chemical property of transition elements. The group 1 elements, group 2, like the normal metals, do not form catalyst. So that's why if you know this single information, that transition elements are the only ones that form catalyst. For example, iron, going up, what was the catalyst for the Haber process? It was iron, and iron is a transition element. That's why it's used as a catalyst. So now we're gonna search in all of these: calcium and lead and sodium and sulfur. All of them are from like group 1 and 2s, and like they're also non-metals, so we don't use them. Platinum is a transition element, so it must be platinum all the way. Now now state the oxidation number of nitrogen in NH3. If you want oxidation number, here's all of it about calculation, okay? So first thing we need to know that the overall charge of the compound is 0 because they wrote it as 0, okay? Here is 0, here is 0 because they gave us no charges. For example, NH3 minus, remember? So the overall charge is minus. You see, you need to look at the very top of the compound. So on the very top of the compound, they gave you nothing, so it's 0. So now we know H is like 1, right? So let me make it smaller because I don't have space. So you know that H is 1, right? But since it is H3, it's going to make it as 3, 1. And we know that all of this equals to 0. Now N, let us say that we don't know it, so we're going to make it as X. We plus them together, so these two will be equals to 0, okay? Because in the question they want us to find the oxidation number of nitrogen. The oxidation number is same as like the charge, okay? Like for your own knowledge, like the charge of H is H plus, so it's 1. So that's why. So now it's X plus 3, 1 equals 0. Then you're going to be asking, why don't we put like 4 for them all? We don't do that, okay? So you don't look at the number in here. You don't look at the moles number. Please don't do this mistake ever in any calculation of the oxidation numbers. We don't need that. You only care about this. For example, if there was like N2 or something, you're gonna do 2x, okay? Don't care about this, please. So it's this, okay? So now X plus 3 equals 0. X, we move 3 to the other side, it's gonna now be X minus 3. So now we know the oxidation number of N is minus 3. The charge is so important, okay? Now for NO, the very same method. So O, we know that the charge of oxygen is O2 minus. So you're gonna write minus, okay? And please make sure that you need to write the charge of it. You don't only write that like 2 by itself. It's so wrong. You need to write minus 2 also. And now the same thing for nitrogen. And now the same thing, that is equals to 0, right? And now for nitrogen, we don't know, so it's going to be X plus minus 2 is going to be X minus 2. So it's the same. So the same method. Move minus to the other side, is going to be X2. So now 2. Now there's some easy 2 marks, and it's so important to know how to find the oxidation number. There's plenty of questions about it, paper 4 and paper 2. Now triple I says, use your answer to II to explain whether the nitrogen in ammonia undergoes oxidation or reduction. So oxidation, you can make it an easy, simple way. It's that the oxidation number increased from, like, example, from like 2 to 7. Okay, so it's an oxidation because it increased. If it was from like 2 to -1, I mean, it's decreased, so it's a reduction of oxidation. Okay, they could also think about it, oxidation is the loss of electrons. Okay, and you can also think about it for oxidation as like gain of electrons, but like you can use plenty of ways for it, but like the easiest one for now, since you know the oxidation number from these two, you can know that you increase the number from 2 to 7, means it's oxidation. If a number decreased from decreased from like 2 to -1, means it's reduction because it's no longer increasing. Now again, to explain whether the nitrogen in ammonia undergoes oxidation or reduction, so from -3 to -2, -3 to -2, so it was first thing in, like, let me just put this a little bit higher because we're done. From -3 to -2, okay, so it was first thing like below 0 until it became above 0, so there's an addition, right? So there's an addition of the oxidation number, the same as this method, so it must be oxidation. Okay, and the mark scheme says oxidation and oxidation number increases. Like, I know even that there's 1 mark, okay, but even if there's 1 mark, just write everything you know about whatever you want to answer. So oxidation, then you're gonna be like, why? Because oxidation number increase, because -3 to -2 increased. Okay, so the mark scheme says oxidation, and so it's important to write the other point. Now complete table 3.1 using the word increase, decrease, or not change. Okay, these questions are so easy for me. In this type of question, you need to know what happens if decreasing pressure or increasing temperature, and what happens, and so on. Now, effect on the equilibrium yield of NO. Decreasing the pressure. Okay, what happens if we decrease the pressure to the yield of NO? So where's the NO? NO is in the product side. Okay, so decreasing the pressure. Okay, need to know first thing, decreasing the pressure will help the side with the highest moles, will favor the side with the highest moles. How do I know? And like, what do I mean? It's first thing, there was here 4 and 6, right? So like 6 plus 4, 6, 7, 8, 9, 10. I'm sorry I'm adding, but like in case, so there's 10 moles in here, right? 10 moles in the product side. Now for this side, there is 4 plus 5, which is 9 moles in the reactant side. So as I said, that the decreasing pressure will favor the side with the highest side of moles, so it must be the product side where the NO is there, so NO will increase for sure, so we write increase. Okay, I'll come back to this later because let me just finish from this column first. Now decreasing the temperature. Decreasing the temperature means this one need to learn. Okay, decreasing temperatures is an exothermic reaction, right? Whenever they're asking you about exothermic, whenever they're asking you about like finding the temperature, what happens in its equilibrium, you need to know whether the equation is exothermic or endo. Okay, so since exothermic, like from the way I use is like exothermic is like this, right? So you know that the energy is higher in here, energy is lower in here. So like the same, the pressure is higher in here, the pressure is lower in here, right? So like decreasing temperature, it's gonna be decreased in here, right? So it's in the reactant side. Since the NO is also in the reactant side, it's also increase. Okay? Now removing the catalyst is this one important point I want you all to know. Catalyst will never affect the equilibrium. This this question is like will be a tricky question. You're gonna be like decreased because there's like catalyst gonna speed up the reaction. If there was no catalyst, and it will decrease the reaction. It will never do that. In the equilibrium, okay, the equilibrium, the catalyst will never shift like the equilibrium to be into the product side or the reactant side, like the pressure and temperature. It will never do that. The catalyst will never do any changes, so you must write no change. You need to remember it. The catalyst never changes the equilibrium. Now coming to the effect on the rate of forward reaction. Forward reaction is like where products are formed. Now when you're talking about the rate, we're not talking about the equilibrium. Just gonna make it like general knowledge. Whenever you're decreasing the pressure, it means that there will be like more particles. It's gonna be decreasing. And like decreasing the pressure, gonna be like the particles will be like less in kinetic energy, so they won't be going so fast. They're gonna be decreasing. Removing the catalyst gonna be the rate of our reaction gonna be slow, so it's gonna be decreasing for sure. But like equilibrium and the rate is different. Rate is like you're gonna use your general knowledge from your physics and you're gonna know like what happens if it decreases and increases. And equilibrium is where the sign shifts. Now V decreasing the temperature causes the rate of forward reaction to decrease. That's right, okay. Explain using theory why the rate. So again, when they say rate, you only talk about the general knowledge of whether it decreases or increases. The reaction is slower at the decreased temperature. Why the rate of reaction is slower at the decreased temperature? So it's easy. You know that the kinetic energy is lower. So if it's lower, it means the frequency of collisions must be lower, must be less or lower. The stream marks. The mass game says kinetic energy of particles lower, frequency of collisions between particles is lower, and like fewer particles have energy. Okay, so you need to also mention that the particles have less energy. Okay, need to mention the energy because the particles have no energy, so that's what they got lower. And when you talk about the pressure, also for your own knowledge, the pressure have nothing to do with energy. Okay, the pressure does not increase or decrease the energy, only the temperature. I mean, not the kinetic energy, only the temperature. Okay, remember this. Now C is only about balancing. In second stage, nitric acid is produced. Balance this equation. So let's start from the easy one. So let's see how much we have here. One nitrogen and one nitrogen. Let's go with oxygen first. We have here 3 oxygens, right? No, this the product, this the reactant. So we have here 1 nitrogen. Okay, we have here 4 oxygen. We have here 3 oxygen. What if I put here 4, like to make them the same? So 4 in here and then 3 in here. So now I have 3 multiplied 2, which is 6. 6 with the 1 in here is going to be 7. Oh, now 4 with 3. Wait, it's going to be here 3 with 2 is 6. So 6 with this 7. 7 with this one also is going to be 8. So now 4 with 3 is going to be 12. Oh, okay. What if I added like, so it's now 8 in here, right? 8. Oh, what if I added more, like a 2 in here? So it's now like 6, 7, 8, 9, 10. So there's now 10 O. 10 O. So I need to also make it more. So what if I added also another one? So now 2 with the 1 is gonna be 2. It's now 12 O. So let's check the hydrogen since we changed the hydrogen. So now there's 4H in here. And there is just also 4H because 2 multiplied 2, which is 4H. Let's check the nitrogen. Nitrogen was here 2. And here is 4. So what if I move 2 and put 4? Gonna be now 4 and O. Now let's check the oxygen again. 4 O is 4. Then 6, 7, 8, 9, 10, 11, 12 is that 2 of here. so it's correct. I know this is confusing, but need to like keep on trying. Okay. Question 4 is they give you this information and this equation, then the mixture is then filtered. Okay, let's just read the question. Okay, zinc reacts with dilute sulfuric acid. Aqueous zinc sulfate is one of the products. Powder zinc is added to dilute sulfuric acid. The mixture is stirred. More zinc is added with stirring until the zinc is accessed. For your own information, zinc is soluble. So like whenever soluble meat, it can be made from anything. It can be made from soluble and insoluble, or soluble with insoluble. Okay, so I mean, it can be made from soluble and insoluble. It can be made from soluble and insoluble. So whatever, it's fine with you. They said the mixture is then filtered. Why they said it's filtered? Because they said that until the zinc is in access, so they added more zinc. They added zinc in access, so it's no more dissolved. So that's why we filter this stuff. We need to move it. So name the limiting reactant. So the limiting reactant, need to learn that limiting reactant is like the one that is not added in excess. The one that is not added in excess, which is, since zinc is added in excess, it must be the sulfuric acid. So dilute sulfuric acid, just remember this. State 2 observation that indicates the zinc is access. This type of questions are so common, you need to know them by now, that like solid remains of zinc, that's why we like filter them. That's the first point. And then there's no more reaction, so there's no more bubbles stops, or bubbles no longer forms. Okay, now name the filtrate. Again, what is the filtrate? This is the filter paper, right? The filtrate, first thing, the residue is here, the filtrate is here. The residue is like the insoluble substance because it stays here. The filtrate goes down, which is the soluble substance. So name the filtrate. Since the zinc SO4, again, as I said, it is soluble, so it went down into here, so it must be the filtrate. So it's CnSO4, or if you want to write it exactly as the I'm asking, it's aqueous zinc sulfate. But if you write, it's going to be correct too. Okay, but since I said like name, so like name it like in words. Now Ivy says name 2 compounds which both react with dilute sulfuric acid to produce aqueous zinc sulfate. You need to add something that have zinc, then whatever you want to add. Okay, so you can add like zinc oxide. Zinc oxide will work. Like zinc oxide with sulfuric acid gonna make zinc sulfate plus another products. You can also write zinc carbonate or zinc hydroxide, it will be fine. So zinc carbonate with sulfuric acid gonna give zinc sulfate with like CO2 in like addition, but like main thing that it will give this. So these are correct. Now B, state what is meant by term saturated solution. Saturated solution, you need to know that it means that it will no longer allow any solute to dissolve in it. For example, if there was like a solution which is saturated, so if we added more of like a substance like dissolve in it, it will no longer dissolve, it's just gonna stay there. That what it means, that this solution is now saturated. It won't allow any more solute. The solute is like what we add to dissolve, so the solute will no longer dissolve, so the solution is saturated. So what will you write is the mass game says maximum amount of solute dissolved, means that there's no longer dissolved anymore. Okay, in given temperature, this is will give you the second mark. Okay, like in given temperature means that, like, you know, if like you heated the solution, okay, like it will become less concentrated, so it will allow more of a solute to go. Okay, and that's why you need to make given temperature means that if there was no change in temperature, it means it will stay saturated. There will be no change. But if you added like heat in it, and the particles will be like able to like absorb more, I guess it will allow to dissolve. That's when you need to write and given temperature. Now explain why crystals from no why explain why crystals form when the saturated solution cools down. So there's a change in temperature, okay? When the solution cools down, you need to know. In this of question, when it talks about the crystals and saturation, you need to remember this exact answer is about the solubility. So since that cools down, the solubility decrease. So will it decrease with decrease of temperature? What do I mean is that like the same example of this, okay? As I said, like if you heated it, okay, and it was in its concentrated form, I'm sorry, if it was in a saturated form, okay, it would like allow more. But if you like cooled it instead, you put it in a freezer or something, it will never allow more solute. Like there's no chances to allow more solute to dissolve. That's why the solubility decrease. It means that solubility means it won't allow any more solute to be soluble in it anymore. That's in the possibility of being cooled down. But at temperature, it will allow more solute to be soluble in it, so it will dissolve and make it less saturated, okay? Now C, state the term used to describe crystals that contain water of crystallization. We know it's hydrated. For example, hydrated copper sulfate, we know it's hydrated because it contains water. Those are some easy questions, hydrated for sure. Now, state why step 4 is repeated until there is no change in mass. Let's read step 4. The remaining solid is heated again, allowed to cool, and is then weighed. So you see that the solid is heated again, so they're like removing the water for sure. They're heating it from the water because this point means there is water, okay? And also they're heated to give water, so they exactly give you the answer. So the answer must be like to ensure all water of crystallization is removed. Okay, it's just you want to ensure it, that way repeated it. And now some stoichiochemistry type of questions. Calculate the number of moles of NiSO4. N equals M over MR. So M, they gave you that. Let's read the question. 0.55 nickel sulfate crystals. Nickel sulfate crystals is this. So they're not talking about it now. Then is used. The mass of anhydrous nickel sulfate NiSO4 that they want remaining is 0.310. So they gave you this mass, and they gave you its MR2. So I'm gonna substitute it now. My charge is less, it's fine though. The mass is now 0.310, right? Divide MR, which is gonna be what they gave you, 155, and your answer gonna be 0.002. Now calculate the mass of H2O given. You won't be able to use the moles because when you look at it, it did not give you the moles of it, so you cannot like compare the moles of it. But like instead, they gave you that like the total mass of like the full reaction was this, right? They gave you its mass. They gave you the mass of this. So for sure the mass of this gonna be the minus of the mass of this to give the mass of this. Okay? The total mass was the reactant mass, since there's only one reactant, who's gonna be nickel sulfate crystals. So this that gave the mass of NiSO4 was gonna be one of their products. So like this minus this is gonna give you the answer of the other compound, which is H2O. So 0.54 no 0.454 minus 0.310, it's gonna be 0.144. That's, you found an easy way to find the mass of H2O. Calculate the number of moles of H2O given. Now you can find it for sure because you know the moles. Now it gave you the mass. So now N equals M over MR, right? So that mass they gave you 0.144 over mr they gave you here, which is 18. You put it in the calculator and you will get it as 0.08. Okay? Now the last thing is calculate the value of x. This is the x. So we know that x of this is going to be the same as x of this because they're like the same symbol. Okay? So how do we do this? We know first thing we can use like a comparing method. Okay, so how will you know if we don't have the moles of H2O? First thing we know that this much, we know that moles of Ni is over 0.002 equals to 1, right? Because like there's nothing in here, so it's like 1. So what we're first gonna write is we know that 0.002 equals to 1. Let me write it there, wait a minute. 0.002 of moles equals to 1 mole in the equation. So now we got of H2O, we got 0.008, but we don't know what's equals to, and this is where we're gonna find it. We cross multiply, it's gonna be now 0.008 divided 0.002, and it will be 4. So you know the value of x equals 4, so for H2O, it's 4H2O. And the same for this is going to be NiSO4 dot 4H2O. It will be a tricky question at first, but it's easy, trust me. So now we have question 5. Okay. So question 5. The question is about iron. Okay. Describe the bonding in a metallical element just as iron. So in metallic element, you need to know it's like only a metal. Okay. It's like positive charges. There's nothing with like, it's not compound, it's not bonded with any minus electrons. I mean any minus ions. We don't do that, it's wrong. So may include the labeled diagram. So you can use it to explain. You have plus plus plus, just like the normal ions, right? Make sure like to make it neat and make it the same size, but since it's not accurate here, it's fine. And then what you need to know is also have some like it has some free delocalized electrons, not negative ions, but free delocalized electrons. Make sure like to add them in the spaces because it's like everywhere. There's no circles, I'm sorry. E minus, E minus, E minus, E minus, E minus, okay? So I guess you got 1 mark for this. We need to explain more. So first thing, why you saw in here it have positive ions, right? Positive ions with, so that's 1 mark, with C of delocalized electrons. Delocalized means that they are free to move, okay? And then with them attracting, or like attraction of them. Attraction is also the 3rd mark. So this is important to write attraction, okay? Because like if they're not attracting, how will they like held in place? How is a metal like a solid sometimes? So it must be attracting. So the positive ions are attracting the 3 delocalized electrons. That what explains it. That what the mark scheme says, and it's correct. Explain why iron conducts electricity when it is solid. Why? Because it have 3 delocalized electrons, or electrons are moving. Electrons move, electrons mobile, electrons flow. That's what the mark scheme says. Now B is about the extraction of hematite. My charge is 4 now, but it's fine. Give 2 reasons why coke is carbon is added to the blast furnace. We know that carbon, need to learn this, you need to learn. You can know that, you can go to like YouTube videos, it explains very well, okay? So we know that coke releases heat. From its reactions, it releases heat. You need to know this point, it's like important, it comes sometimes paper 2. And what happens is that it reduces iron. If you don't know what I'm talking about, go to YouTube channels because they will explain this full think about it because it is important to know that it reduces iron because the carbon reacts, not carbon itself, but like carbon will form like C plus O2 will give CO2. And then CO2 will react with more of C to give CO. And CO will react with iron oxide because CO is like a reducing, no, CO is like an, yes, CO is a reducing agent and it will reduce iron oxide. Okay, so I need to know these equations, please. Just learn about it. It's 3 now, but it's fine. Explain how limestone removes the impurities in hematite. How limestone removes the impurities in hematite. Okay. So limestone, so there's something called limestone. Limestone is CaCO3. Okay, so CaCO3 is like what we start with to remove the impurity. Okay, but like not CaCO3 is the exact thing to remove the impurity. CaCO3, like I'm explaining it for you, this explanation. CaCO3 will decompose into CaO and CO2. You need to know that in CaO, which is the lime, will react with the impurity. The impurity is the silicon oxide. Okay, so that question says, the mark scheme says, limestone decomposes to calcium oxide, exactly this. Let me write it. Limestone decomposes to calcium oxide from this to this. The second mark is like, what does calcium oxide does? Calcium oxide, since it is a basic oxide, right? It neutralizes silicon, and silicon oxide is acidic. That's why we wrote neutralizes. Okay, again, please go to YouTube and learn how to solve this. Now I write a simple equation for the conversion of iron trioxide to iron in blast furnace to iron. Okay, this one is like an easy question. This one explains this reaction because CO reacts with iron in here to give iron. Okay, so it reduces it. So just write it. Fe2O3 plus 3CO. 3CO is like 3 is like after it's balancing, just learn how to balance it. Plus 3CO equals Fe. So Fe is like what we want, with like some other waste product with 3CO2. Okay, need to learn this. Now suggest why the iron produced in the blast furnace is molten. Molten is gonna be like why like the one that is formed is like molten. Why the iron is molten, not like solid? It's like there's a sensible answer. Is like temperature in furnace is like higher. Temperature in furnace is higher than melting point of iron. Okay, the temperature of this furnace is like where it was higher than iron, that's why the iron became molten. Now see, most iron is converted into steel. Steel is an alloy. Okay, steel is more useful than pure iron because it's harder and stronger. As properties of an alloy. Explain what the structure of alloy causes them to be harder. So it's like I'm gonna explain it now. You may include the diagram. So what is it about? It's like, look, so why is it like strong? So what is the difference between it and a normal metal? Steel is like, say that this is the steel. Okay, I don't remember the symbol of steel, but just write steel for now because I'm only explaining steel and like some iron. Okay, so what you're gonna see that there's difference in its sides, right? Steel, another steel, some iron. So you're gonna see that there's difference in its side, right? This big, this small, this big, this small, this big, this small. So since there's difference in its size, it shows that if you wanna like move it, it won't be able to move because they are not symmetrical in shape, so they will be hard to move. This phenomenon exactly explain the alloy. Alloy is like they have like different sizes. That's why when you wanna think about it, like to be soft, they won't be able to slide over each other because they're in different sizes. That exactly explains it. So you need to write now about it. But let me first charge my phone for now. I'm gonna come back. Okay guys, anyways, as I said, now after you know about it, so we're gonna write that atoms have different sizes. Okay, and what does that mean? What does that do? It says that layers, as I said, layers cannot slide past or over each other. This is the Mars game. Now the iron forms rust. Rust is iron, is hydrated iron oxide. Need to learn this. Rusting is prevented by coating iron with zinc. Name the substance that reacts with iron to form rust. I will think that it's oxygen, okay? Oxygen is right. But since I said here is hydrated iron oxide, it's plus water. The mass scheme says oxygen and water. So if it says and, so I won't get the 1 mark. If I only wrote oxygen, need to write also water. Okay? So name the process. Now this is important, by the way. We need to know that. What is rust? Rust is hydrated iron oxide. This is important to know. Name the process in which zinc is used to coat iron to prevent rusting. You need to know this. It's galvanizing. Explain how the coating of zinc prevents rusting if the zinc is not scratched. If it's not scratched, that yeah, talk about iron. So this iron, so zinc is like covering it, so that's what it means. So what does it do? So if there's like water and oxygen outside, it won't like allow it to touch the iron. That's what they mean. So what they're gonna write is like it acts as a barrier to iron. Now when zinc is scratched, the iron becomes exposed. Okay, so it was iron again. It's scratched somewhere, so there's like a place for oxygen to join. So explain how zinc continues to prevent rusting. Since zinc is like higher in the reactivity series than iron, so it will like start to lose electrons, since metals lose electrons, right, forming positive ions. So zinc will react instead of iron because it's iron in reactivity. So zinc is more reactive, and then you're gonna be like talk more about it. So zinc is like oxidized. So if you're gonna say first thing your reason, you're gonna like tell them like why did you come to such an idea that zinc loses electrons. Gonna be like because zinc is more reactive. Then like zinc is oxidized mean losing electrons, or you can write zinc is losing electrons instead of iron because it's like more reactive. You're gonna have now the 2 marks. Question 6. Ester are members of the homologous series of organic compound. Give the characteristics that are same for all the members. This type of questions are so common in the past papers. You need to know them by now. Same general formula under functional group. General formula is like CnH2n. PnH2n is like for the alkene. I remember, I guess it's like H2n, right? For the alkane is like CnH2n plus 1 plus 2 plus 2. Okay, and the functional groups, for example, for like carboxylic acid is like CH3, okay, COOH. So they're like the same for like anything you want. Okay, like C3H2COH. For like this is like for like methanoic acid is for like ethanoic acid. They both have COH, that's why they're the same. Now ester X is a structure in figure 6.1. This is it. Name the ester X. Name the X. So this is the alcohol side, this is the carboxylic side. So now it's like it's gonna be ethyl Propanoate, you need to learn how to name them. So first you need to name the last side, just the alcohol. It's gonna be now ethyl. So you need to write "il" and then prothanoate. The 8 gonna come for the carboxylic acid. Okay. Ethyl means 2. See, they showed in here. Prop means it's 3 carbons from here also. Now see, I named the alcohol and carboxylic acid to make ester Y. Not this, you're not talking about this, you're talking about this. So now we're gonna look after this, you're gonna look like this, okay? Because like COO comes with the carboxylic acid, so the carboxylic acid shows it's only have 1 carbon. So now it's like methanoic acid. We're gonna look after, it's gonna be all of them. You have like 1, 2, 3 carbons. Just like propanoic. Now, this is alcohol, right? It's propanol. Propanol, I'm sorry, my handwriting is so bad. Propanol. Now state the molecular formula of ester. Molecular formula is like the normal formula. The empirical is like the simplified formula of the molecular formula. So I'm just gonna count it easy. So ester have like 1, 2, 3, 4. So you're gonna write C for how many hydrogen? 8 hydrogen. So it's gonna be H8. Don't forget the O's, okay? So we have O2. That's it. Ester Z has a molecular formula of C for 8, C for H8O2. See the empirical formula of ester Z. Empirical formula is simplified formula of the molecule. So just like divide them both by 2. You're gonna get C2H4O. Okay, the mass scheme says the same, so you're good to go. Now they gave you this. Now we're about polymers, okay? This is the polymer side of the last chapter. State of the organic. I just remembered the name chapter in organic chemistry. Okay. State the term used to describe the type of polymerization used to produce polyesters and polyamide. You need to remember it all the way. Condensation. And the ones from like that goes from like alkenes into like polyalkenes. Alkenes, okay, alkenes to polyalkenes are called addition. Polymerization, okay? These are just condensation, just polymerization. Polymerization is from like the alkenes into polyalkenes. The condensation is like when there is like two functional groups. For example, let's see about this. Show the structures of monomers used to produce nylon. So like nylon have like two types of functional group that will form it. So show all the atoms on the bottom. So since nylon is like nylon has an amide linkage. Okay. Amide has an amide linkage. So you need to know it. And so it consists of carboxylic acids and consists of like another one which like it's like NH2, okay? To form, remember it was like CH and H. Okay, it was something like that. I mean CO. It was CO and H, but like make sure to remember it. Make sure to know about it. It was like CO and H. This is the amide linkage. And they're combined of these two added together. So now they want us to draw them, so let's draw them. So let's say it was a carboxylic acid, right? COOH, COOH. You can write it anyway, so it's fine to write it like this. You won't lose a mark, but I really don't know. But the mass scheme like says the exact way to do like this, but there is no difference. Whatever is easier for you. For me, that's easier. Okay. You can write it this way. I'm sorry. You can write it this way or this way. They're both the same. And now the other type of linkage, we have, the other type of monomer to react with it to give nylon, what is NH, like this. Also the other side the same, NH. And that would explain the condensation. It have like one monomer with like different functional group, another polymer, another monomer with a different functional group. That's what I meant by condensation. That's the last part. Naturally occurring polyamides are found in food. Is it given to naturally occurring polyamide? I need to learn this. Proteins. When I say naturally and then I say polyamide because proteins have like the same linkage as nylon. Please learn this, okay? But like the only difference that proteins are not just like natural, okay? Now name the type of monomer which forms naturally occurring polyamides. So what forms the proteins, from your biology is amino acids. So I can say that we now finished this past paper, and I hope it was useful, and thank you for watching.